H-boys on.
Go for engine start.
H-boys are on and engine starts has been okay. Engine starting up now.
And all personnel, we've got engine start and we're into the plus count. All personnel, please continue to monitor your systems and grass is in control.
Welcome to the post-test briefing for the hot fire test of the core stage for NASA's Space Launch System rocket. The hot fire is the 8th and final test of the Green Run test series, a comprehensive assessment of the rocket's core stage prior to launching Artemis missions to the moon. During the test that took place today here at NASA's Stennis Space Center near Bay St. Louis in Mississippi, engineers loaded more than 700,000 gallons of cryogenic or super cold propellant into the tanks and fired all 4 engines at the same time for a little over 8 minutes to simulate launch. Here to talk with us about the hot fire test are NASA Acting Administrator Steve Jerzik, Tom Whitmire, Deputy Associate Administrator for Exploration Systems Development at NASA Headquarters, John Honeycutt, SLS Program Manager from NASA's Marshall Space Flight Center, and Julie Bassler from SLS Stages Manager from Marshall. Also joining us on the phone for the Q&A session, we'll have Maury Vander, Chief of Test Operations at Stennis, Johnny Heflin, SLS Liquid Engines Manager from Marshall, John Shannon, Vice President and SLS Program Manager of Boeing, and Doug Bradley, Deputy RS-25 Program Manager at Aerojet Rocketdyne. Our speakers will each give a few opening remarks from the speakers here on the stage, and then we'll take questions from reporters on the phone. For the reporters on the line, you can enter *1 at any time to be joined into the queue. Your phones are on mute now, and the operator will open your mic to ask your question and close your mic when you're done. First, we'll hear from NASA Acting Administrator Steve Jerzik.
Hey, good evening, everybody. So first, what a great day and a great test. And right up front, I just want to say how proud I am of this team. Many of the team members have been on the program for a lot of years and have worked really hard to get to this point, including the past year during all the challenges we've had with the global pandemic. And I just could not be more proud of the team, of their talent, dedication, getting to this point and pulling off a just very successful test. It's been a really actually great year for NASA during a very challenging year for the nation and the world. We had the first launch of astronauts from American soil in almost 10 years with the Demo 2 launch. We followed that up with the Earth Science mission, the Sentinel-6 Mike Freilich launch, then the Crew 1 launch, our second crew launch to the International Space Station, and then in February, the Perseverance landing, and now the Green Run test. And so I am so grateful and proud for the NASA team, our industry partners, our academic partners, and our international partners that work together to pull off these amazing accomplishments. And I am proud and humbled to be a leader of this organization. So what does this mean for our plans? Well, this is a major milestone in advancing our goals and objectives for Artemis. To land the first woman and the next man on the surface of the moon, and to return to the moon, this time to stay, to explore the moon sustainably, demonstrate the capabilities and technologies that we need to eventually achieve a human mission to Mars. So not only critical for our Artemis plans, but critical for our overall Moon to Mars plan and achieving that ultimate goal. And this test will allow us to continue the integration of the Space Launch System, the largest, most powerful rocket ever developed, which we're going to integrate with the Orion spacecraft and do an uncrewed test flight, leading to a crewed test flight, and then that first landing mission on the moon. And the SLS and Orion, along with the Gateway and the Human Landing System, the first human-rated landing system in development since Apollo, are the backbone of the systems and the architecture that we're going to need to accomplish these goals and objectives of a permanent and sustained presence around and on the moon. So this is a major step in advancing our goals And again, couldn't be more proud of the team, and I just almost speechless about how well things went today. So thank you very much.
All right, we'll go to Tom next.
Okay, and I agree with Steve's comments. This has just been a tremendous day. Congratulations, John and Julie, your teams, the other teams represented here today, and everybody that worked all those years before today to actually have a design, a manufacturing facility, everything that goes behind a rocket. It's very amazing accomplishments. This was the last really big development test we needed to complete, get behind us. And in our program, we take it a step at a time. This was a really important step for us. John and Julie will talk about the next steps in terms of reviewing the data and seeing what we got out of the test. Generally speaking, it's going to take about a month to complete refurbishment. Then we will ship it down to the Cape. It goes down the Pearl River, through the Gulf, down the tip of Florida, and into Cocoa Beach. And we then into the Turn Basin. And for those folks that are familiar with the VAB, we actually go into the VAB, and we go to the right at the very end. That's High Bay 3, and we're going to put it right in the stack. We've got the boosters ready to go on the ML. We've got processing going on Orion. And I just can't agree with Steve more. A lot of us are going to look back at this day later in our careers and our lives, talk to our families and friends and significant others, and say we were here for a very important test for the most powerful rocket ever built. And I think that's just an incredible accomplishment. For terms of what happens after this, once we get to the Cape, we'll take it a step at a time. We have a lot of very specific activities that will occur next, a lot of stacking operations, integration operations, test and checkout. And when we accomplish those operations, we'll be ready to fly. And just as we've done today, we'd like to take that a step at a time. We'll see how we do later on in the year. We're very excited about that, and it's going to be very visible. We're going to bring everybody along to kind of follow us as we go through the year, and we're very excited about that. So I'm going to turn it over to John. Congratulations, John.
Thank you, Tom. I have to tell you that it was very exciting to see the test today. You know, this was a culmination of a series of tests, and I just couldn't be more excited and proud of the team. You know, it's been several years since I experienced the vibration and the sense of the power and the feeling of a rocket like this. And it literally just gives me cold chills whenever I get to experience that. And I think what it does for the team, it's really it's the fruits of their hard work, and that's extremely important, and that's what keeps driving this team. We've had some challenges with this green run, and I'm just so proud of the team with the way they've methodically worked through these challenges, and just the work that they've done got us to where we are today and got us to a really good test. All the data that we have looked at so far, and we've got a lot more to look at, but everything that we've seen in the test today looked nominal. So I would say the core stage, Julie got an A+ today, and so I can't go without thanking Julie and the stages team, all the folks in the SLS program, our prime contractors, Boeing and Rocketdyne, and especially our friends at Stennis that provided a great test facility and a great test operations team. I got to see this team work through these series of tests, and the more they tested, the better they got. And that was really evidence today with a good smooth countdown to get us into the test. I would also just like to take just 1 second of time to mention the fact that we did lose one of our teammates this week, and it was Mike Rudolphi. He's one of our forefathers that worked in the program with us, and he will be dearly missed, and we owe him a debt of gratitude for his contributions to get us to where we got to today. as Tom mentioned, we'll be getting on the test stand and assessing the core stage over the next few days and taking a look at what kind of work we need to do on the stage to get it ready to ship. And then at that point in time, we'll remove it from the stand, get it on the barge, and ship it to KSC, and we're really looking forward to that. So, in SLS, we've got all our hardware at KSC, and we've got both boosters stacked, and we're really excited to be able to get the core stage to KSC and get it stacked in between those two boosters. So, Julie, I'll turn it over to you now.
Okay, thank you, Mr. Honeycutt. So yes, it's been an extraordinary day. So a lot of hard work has gone into getting us to this point today. The team is amazing. Every time we test, we learn something new, and they are so resilient. And the team that pulled together today, the Boeing and Rocketdyne and the Stennis and the SLS team, we have met several challenges this year, not to mention the COVID, but also with all the weather challenges we had. We actually had a weather challenge last night, actually. We were watching the bad storms come through, but we had a Stennis team that was on the ready, and they came out around 2 a.m. and got on the facility and finished up all of our pre-test work that we needed to do out on the stand. So at 5:30, when the test team came in, we had a all clear sign, and we were ready to go into test. At 6 a.m. this morning, we did our tanking, go, no go, and we had no anomalies, no issues were being worked. And that was pretty much the way the whole day went. We went through the whole day. We had no significant anomalies. It was the smoothest test, I think, that for sure we've ever ran, and several other people on the team said any test they've been part of. We had no major issues, and we went all the way up to the T-minus 10 minutes, and we did our hold and checked everything, and did the final go, no go from the test team, and went right into the hot fire. So I think you can see from the video and everything that all the data we're seeing now, as Mr. Honeycutt said, everything looks like we were right down the middle of our modeling and our analysis. We have met all of our objectives now. So, we talked about we needed at least 4 minutes. Well, we did twice as good as we needed. So big thanks to the team, and couldn't be more proud and more humbled to be part of such a fantastic team. There was never a point where somebody said, that's not my job. It was all about what do we got to do to get this hot fire off today. So great effort, and I wanted to just thank everybody.
Thank you. We'll now take questions from reporters on the line. Please press *1 to be entered into the queue. We ask that you please stick to one question and identify to whom your question is directed. If we have time, we'll allow reporters to ask a second question. Again, you can enter *1 on your phone to be joined into the queue at any time, and you can enter *2 to be removed from the queue. All right, so for our first question, we'll take Marcia Dunn from Associated Press.
A question for Mr. Jurczyk. I'm wondering what kind of schedule you think you have for this year. Do you think you can launch the first flight by year's end, or do you think it'll bump into 2022? And what about the first moon landing? When do you think that might actually take place? Thank you.
Okay, I'm going to take the moon landing part, and I'm going to kick the launch part to Tom Whitmire. Okay, yeah. So on the moon landing part, we have an internal study that we're conducting right now to look at the missions beyond Artemis 2, and particularly given the appropriations that we got in FY21. Actually, it was really good appropriations in 21, including a good bit of funding for the human landing system, but not what we requested. And so it'll probably take a few months to get through that study. We'll take a look at what we can optimally do given the FY21 budgets and expected budgets in out years, and lay out the mission manifesting cadence beyond the Artemis 2 mission. So we have some work to do there, but we're in the middle of that work right now.
Okay, let me talk about the launch situation. And it's kind of what I've described at the start of the process. We take this a step at a time. We saw that here today. I mean, our goal is to get through certain tests and certain activities, and when we're done with that, we have an opportunity to fly. And so I'm always very careful. I used to do shuttle program, and we're always very careful to say we need to get through every one of these tasks, every one of these activities. They're highly visible events. You'll be able to follow the hardware as it comes from here, travels down to the Cape, is integrated in the Cape. We're already processing Orion. We're loading Orion with fuel. We're already have the booster stack ready to go. And so the real answer to your question is when we complete those tasks, then we'll be in a position to fly. Now, like we saw here at Stennis, these tests were really important. We did learn some new things as we went through that. I think it was a tremendous accomplishment as for the first time flight of a world's most powerful vehicle. We really learned some important things. And so I expect we'll learn some important things when we get down to Florida. It'll be the first time we've used the facilities in Florida. We may come across a few things that we need to address. So I think the real answer to your question is that, we're looking for opportunities this year, but the real answer is we will absolutely keep you apprised of how we're doing throughout the process. We'll let you know what the progress looks like. They're all highly visible events. They're individual integration tasks that are easy to follow. And as we get the vehicle to the Cape, we'll be able to provide additional information of what the process flow looks like at the Cape. And that's the real answer to the question, and then that's where we're at.
Thank you. Our next question is from Irene Klotz of Aviation Week.
My question is for Steve. Could you describe what sort of interactions you've had with the Biden administration, and if you've gotten any indications of how things might be different in the NASA programs, Artemis in particular, but anything else in general that you could see shifting? Thank you.
Yeah, so in general, we've gotten really good support from the Biden administration, pretty much across the board. I have to say I am optimistic about the trajectory that we're on and pretty much staying on that trajectory. Now, with respect to Artemis, I was really excited and glad to see early on the administration communicated their support for the goals and objectives of the Artemis program and our overall Moon to Mars strategy. And obviously, human exploration and human missions, human spaceflight missions are the most complex and visible aspect of Artemis, but we also are conducting robotic missions to the Moon and to Mars. Robotic Mars missions are also part of planning and advancing our goals and objectives for Moon to Mars, as well as technology and demonstrating the technologies that are going to allow us to stay on the Moon sustainably and for the long term and enable human missions to Mars. So I think the administration has really embraced our overall Artemis strategy and goals and objectives, and so far supported that, as well as highlighted other ways in which we contribute to important policy objectives for the new administration, including climate change, and that includes the research that we do with our satellites and instruments, reducing the environmental impact of aviation, STEM engagement. That's really important. One of the important things we do is inspire the next generation and inspire our youth to go into science, technology, engineering, and math, and using the power of diversity and inclusion to advance our goals and solve the really tough problems that we have. So far, I am really excited about the support we've gotten from the Biden administration.
Thank you. Our next question is from Philip Sloss of NASASpaceflight.com.
Yeah, I think this is for Julie Bassler or John Shannon. It sounded like on the audio that you got the low-level cutoff test, the LOX depletion test, but I just wanted to check and see confirm that you did. And anything you can talk about in terms of the process from here to putting the stage on the barge. Thanks.
Yeah, so this I'll take a part of that. I am not familiar, Philip, with any low-level cutoff.
So he's talking about we had the plan to do the low-level LOX cut at the end of the test today. and that went according to plan.
Okay,
So
yes, okay.
I
So,
was
yeah.
looking for you to confirm that.
Okay, yes, we did meet that objective. Okay, now I'm with you, Philip. So, and as far as finishing up what we have left to do, so we'll be doing our refurbishments, we'll be reviewing data, and then we'll do our break of configuration. And then we have about mid-April is what we're targeting right now to do shipping our core stage over on the barge to KSC. And so by the end of April, we're looking at arriving at KSC. And John Shannon, I'll throw it over to you if you want to add anything to that.
Julie, that was a great explanation. Philip, from our initial look at all the data, we achieved all of the objectives, even our secondary objectives. We did see a LOX low-level cutoff, and the system behaved exactly as it should. And so we're very excited about the data that we've gotten. It's terabytes, and we'll be working through that over the next couple of weeks as we do very detailed inspections of the hardware. But the initial look is that everything worked perfectly. And we also can't forget to say that it wasn't just the vehicle that worked perfectly today, it was the B2 test stand. And the work that the Stennis Space Center did to pull off an amazing test like this was unbelievable, and all of their systems just worked exactly like they should.
Thank you. Our next question is from Eric Berger of Ars Technica.
Congratulations, everyone. Looked great today. The engine fire, the cork insulation fire, it seemed like that was expected because of the hot exhaust in the test stand, and I think some of that was planned for. Can someone, maybe John Honeycutt or John Shannon, talk about kind of what we saw there on the screen and why that probably wouldn't be an issue in flight when you're in a different environment? Thank you.
Yeah, Eric, I'll tell you what I know a little bit about it. I'm not a thermal expert by any means, but after the first test, we saw some base heating data that made us look at the amount of cork insulation that we had in the boat tail area of the engine section. The team went off and made a decision, number one, to go ahead and remove those rain covers that were on the engine blankets, and we saw those burn off in the previous test. Number two was to add some cork insulation and some of the reflective tape, and we did that. I would guess had something on the order of probably 4 or 5 inches of cork in layers applied with adhesive. So what you saw there was some of the tape burning off, as well as once one of the layers of cork got ablated, then we'd see the adhesive burn. We don't expect to see that during flight, just due to the environments are different, and the aft end of the vehicle won't experience that same radiative heat load. Well, Mr. Shannon or Julie, if I missed anything there, you guys can chime in.
Yeah, I think you covered it exactly correctly, Mr. Honeycutt. John Shannon, do you have anything to add?
I would just add one thing. While it looked kind of interesting, 2 points. One is we have temperature sensors underneath that cork, and none of those sensors got above 100 degrees, so we were in great shape. The cork did its job. And as John said, after 2 minutes of flight, we're out of the sensible atmosphere, and you wouldn't have any burning like that. So you guys got it exactly right.
All right, thank you. Our next question is from Stephen Clark of Spaceflight Now.
Hi, can you hear me?
Yes, we can hear you.
Hi, this is Stephen Clark from Spaceflight Now. Just wanted to ask about the gimbal profile. I know the gimbal profile towards the end of the burn you did, sort of to stress the system with, I think, low pressure in the hydraulic system as the fuel tanks or propellant tanks were getting lower. How did that perform compared to expectations? And also, have you noticed any damage to any of the foam insulation Have you had a chance to look at that to see what might have to be touched up after shipment? Thanks.
So yes, the gimbaling that we did and all the actually ramp up and down on the engine throttling all matched exactly what we predicted. So right now, the team will go through and look at all that data, but we saw nothing anomalous there, so it looked really smooth. From the data that we do have, we're going to have to go through that more thoroughly, but it is looking like we have a very strong TVC system, and we hit all the ends of the boundaries. We were testing the limits there to make sure that we could fly through any kind of environment, and since this is a generational vehicle, it's something we wanted to test for all future core stages and then the Artemis missions also. And could you repeat the second question again?
Actually, Stephen, we've closed his mic, so Stephen, if you have your second question, you can rejoin the queue, just press *1. All right, our next question is from Will Robinson-Smith from WAAY TV.
Hey everyone, congratulations on the test today. I was curious, since the goal, of course, was initially to reach the 4-minute mark, with the ideal being the 8-minute. Can you talk about what some of the important data that was gathered during that 4-minute interval beyond the 4-minute threshold? Thank you.
So I'll address that, and then I'll turn it over to John Shannon too. Really what we were looking for to get past the 4-minute mark was some of our secondary objectives, and that was the frequency response test. That was the gimbaling test that we did, and also looking at when we throttled the engines up and down, that we could withstand those different loads. John Shannon, do you want to add anything to that one?
I'd just say that we collected a lot of data today. Being able to see the hydraulic system work with very little propellant in the tanks with some aggressive gimbaling was a real stress test for the vehicle, and it just gives us great confidence that the vehicle as designed can handle exactly what it was designed for. The vehicle really performed like a champ today.
Thank you. Our next question is from Jake Robbins of We Martians, and then we'll go to Stephen Clark.
Hey there. Congratulations on your test today. It's really great to see. I know you're not going to be green running another SLS core stage, but I think you will be doing one for the exploration upper stage. And my question is, are there any lessons that you learned from this test today that you want to take forward to the EUS?
Yeah, there's definitely lessons learned there. I think we've learned how to work together as a team and integrate the flight hardware into the test stand. The team's in much better shape just to understanding how the stand operates. We've got some lessons that we learned relative to the things that we need to do relative to how we integrate the EUS into the B1 stand. So I think we've got an opportunity to take our lessons learned and really take advantage of the next green run test that we do on the exploration upper stage.
All right, thank you. And we'll go back to Stephen Clark of Spaceflight Now.
Thanks, Stephen Clark, Spaceflight Now. Just wanted to see if you've had any chance to do any sort of inspections of the foam or any of the insulation on the outside of the core stage since the hot fire was completed. Any significant notes there on what may need to be touched up or repaired before flight? Thanks.
Yeah, so we did notice a couple of places in the inner tank area, which is the structural piece in between the liquid oxygen tank and the liquid hydrogen tank, after the tanking test and the first hot fire that we did. We went and did some pour type repairs to that TPS, and we'll have to do some more work to dress those up, either prior to shipping to KSC or once it gets to KSC. I will say this just overall, I'm super excited to how well the TPS team performed over the last several years. We went through a development process with new materials, and they just did an outstanding job. And the performance of the TPS has just been outstanding. None of us expected that we would be in this good a shape coming out of this test. So I'm really happy.
All right, thank you. Those are actually all the questions that we have, so we'll conclude the Q&A portion. Space Launch System is the only rocket that can send the Orion spacecraft, astronauts, and supplies safely beyond the moon in one launch. The next time these engines fire up, we'll be on the launch pad to send an uncrewed Orion spacecraft around the moon on a flight test for the Artemis 1 mission. To learn more about NASA's Artemis program, follow our progress at nasa.gov/Artemis program.